In this lecture, we're going to learn about return type deduction with references. And we're going to start by looking at a simple example here. Here we have a function called max. It is doing return type deduction with auto, but notice that what we return now are references. One might think that this function is going to deduce a reference, but like we have seen in a previous lecture, if you use bare auto type deduction and what you assign to your auto variable is a reference, this is not going to do a reference deduction. This is going to make a copy. So what you return here is not going to be a reference. It's just going to be a copy of the local variable we have in the function here. You need to be careful about this. If, for example, we had in our main function and try to call our max function like we do here, and try to assign the return value of this function to a reference, we're going to get a compiler error. Because the return value is just a copy of what we have inside the function, it can't really be treated like a reference. If you try to do that, you're going to get a compiler error. But if we just grab the value and use that to initialize another variable like we are doing here, this is going to work fine. But it is just going to be a copy you are setting up here. If you increment your result here, for example, this is going to just affect this variable here. It's not going to affect whichever variable contains the maximum on top here between x and y. You really need to be aware of this. If you want to do proper reference deduction, you need to add an ampersand symbol in front of your auto keyword here. Now if we do this and we return a reference, this is going to be a true reference, and we can go through this reference to affect whichever variable contains the largest numbers between a and b here. And here is a simple example of how we can use this in our main function. We have two variables, p and q. We set up a reference which is going to contain the return value of our max function, and the function is going to return a reference, and we can go through that reference to affect whichever variable contains the largest of the two numbers. So if we go here, if we print p, we're going to print a 10 here. And if we print q, we're not going to print 11 because we have incremented that through this reference here. So we're going to get a 12 here. And the line down here is also going to give us a 12. This is really all I have to share in this lecture, making you aware of the little things that can really throw you off with return type deduction when using references. If you want to deduce references, you have to remember to add this little guy after your auto keyword, and you are going to be deducing true references now. Now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is return type deduction with references. We're going to grab our template files and we're going to put them in place. And we are going to open this in Visual Studio Code by simply dragging and dropping on top of Visual Studio Code here. Let's do that. This is going to open our folder. We're going to open the main CPP file, clean it up a little bit, and we're going to close the left pane here. We don't need it anymore. We are going to put in our function, which is going to be doing auto type deduction on the return type here. Notice that the function is going to be taking in references, and we will try to return these references as is in here. But because we are doing auto type deduction without references, this is not going to deduce references, even if what we are returning here are not references. This is just going to deduce int because that's the type of the variable we have here without considering the reference here. So this is just going to return a copy of the variable that we have inside here. And if we try to use that in main, we will be affecting a copy. Okay, now that we have the function in place here, let's go in main and set up a little piece of code we can use to try this out. The first thing we're going to do is try and treat the return value from our max function as a reference. And this is going to blow up as you might have expected. Let's put in two variables, which are going to be our x and y. X is going to be 10, why not? And y is going to be 45. So once we do this, the return type is going to be int. That's what it's going to be deduced by the compiler here, because even if you assign a reference to an auto variable, That's just going to be a copy. It's not going to deduce a reference. So this is really like we are returning by a value here, and the return type is going to be deduced to be int. If we take what we returned by a value and assign that to a reference, the compiler is going to see that you are doing an inconsistent assignment between types. This is going to be returning an integer, but you are trying to assign an integer to an int reference. This is really not going to work. We cannot treat the return value as a reference. It's just going to be a bare separate variable with a value inside. And the compiler is not going to allow us to do this assignment here. Hopefully this makes sense to you. Let's try and build and see the compiler error we get. And the compiler is going to say cannot bind non-const L value reference of type int reference to R value of type int. And what this is really saying, I cannot treat this value here, which is a simple value, as a reference. And this is what we are trying to do here. So we're going to get a compiler error. This is something I wanted you to see. We're going to comment this out because we don't want to freak out our compiler. And we're going to assign the return value to a simple variable like this. And now you see that this is going to work. The compiler is happy, but this is just going to be a separate variable with the value returned from the function as a value inside. That's what we are doing here. If we try to increment result is going to change, and a result was 45 here. Result is going to be 46 if we hit this line here, but x and y are not going to change because result is not a reference. You can do whatever you want with result. You're not going to be able to affect x and y through this result variable here. So x is going to be 10, y is going to be 45. Let's say that here to be super clear, and try to run the program and prove that we are not making this up. So the build is good. We can clear now, and we're going to bring up a terminal and clear and run Rooster. You're going to see that x is 10, which is what we expect. Y is 45, what we expect. Result is 46 because the incrementation here only affected this variable, which is really a copy of the return value. Now, this is not going to be deducing our reference, but what if we really want to deduce a reference? What do? Well, we know what to do. We can add an ampersand symbol after the return type here. And if we do this, this is now going to deduce a reference. If we change the code to this, this is going to still work, but this is not going to be a reference here because int result here is not declared to be a reference. If we run this code with our function returning a reference like this, we're going to still get the same results. We're going to get 10, 45, and 46 because, again, result here is not a reference. We're going to build and see what we get. I really want you to see as many examples as possible because these things can be really confusing for many beginners. Let's run Rooster now. We're going to see that 10, 45, 46. This is going to be just a variable initialized with whatever is returned from the max function here. But if we want, we can treat the result as a reference as we have on top here. If we do this, we're going to be returning a reference. And this is not going to give us a compiler error because the compiler is going to deduce the return type as int reference here. Because we are telling it to do so, we are adding this ampersand symbol after our auto keyword here. Now, if we increment result is a reference. The incrementation is going to affect whichever variable contains the largest value, and that's going to be y. Now, this is going to print 46 here because y was also affected. Let's build and see that this is actually the case. Okay, the build is good. We can clear and run Rooster, and you're going to see that y is 46 and result is 46 here. I really hope now you understand that if you want to truly deduce a reference, you will need to add the ampersand symbol at your return type. And when you do that, the function is going to deduce a reference, and you are going to be able to use that to affect and change your variables however you want. This is really all I had to share in this lecture. I hope you found it interesting. In the next one, we're going to see that if you want to use return type deduction, you can't really split your code into declaration and definition. Go ahead and finish up here and meet me there.